Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the derivative rules to solve these word problems. So as per the first problem, a subway train travels from one station to the next in 2 minutes. Its distance in kilometers from the first station after t minutes is s at t equals t squared minus 1 over 3 t cubed. And we have to find at what times will the train have a velocity of 0.5 kilometers per minute. Now the first thing we are given is that the train travels from one station to the next in 2 minutes. So that means the value of t, which represents the time in which it travels from one station to the next station, should be between 0 and 2 minutes. So t should be greater than equal to 0 and less than equal to 2. So that's the domain of this given function. Now we are given the position function and we have to find the time at which the velocity will be 0.5 kilometers per minute. Now we know that the velocity function is the derivative of the position function. So the first step here is to find the derivative of this given position function. So our first step is, so the prime of s at t is equal to the derivative of the first term, which is t squared, minus the derivative of the second term. So 1 over 3 t cubed. Now we have to find the derivative of these two terms to get the derivative of the position function or the velocity function. So s prime t equals, now for the first term we can use the power rule of derivatives. So we can move the 2 from the exponent to the front and subtract 1 from 2. Now for the second term we can move this 1 over 3 coefficient to the front using the constant product rule. And we have to now do the derivative of t cubed. So now in the next step we can simplify the term, so we get 2t because the exponent of t is 1. We do not write 1 as an exponent. And in the second term, so here we move the 3 to the front from the exponent and we subtract 1 from 3. Now as I mentioned earlier, so the derivative of the position function is the velocity function, so we can also write it as, so v at t equals 2t minus, so here we can multiply 1 over 3 by 3, which is 1, so we get t squared. Now the given velocity is 0.5 equals 2t minus t squared. So this is the equation we have to solve to find the times at which the velocity is 0.5 kilometers per minute. Now this is a quadratic equation because the highest power on the variable is 2. So first we can move all terms to one side of the equation and set the equation equal to 0. So we can move the negative t square and the 2t terms to the left side. So we add t square to both sides. So that will cancel out the t squares on the right side and we should subtract 2t from both sides. So the 2t's on the right side cancel each other out. So we are left with t squared minus 2t plus 0.5 equals 0. So this is the quadratic equation we have to solve to find the value of t. Now we cannot use factoring because one of the terms is a decimal number. So here we can use the quadratic formula. So the first step is to write the quadratic formula. The quadratic formula can be written in terms of t here. So t equals, so negative b plus minus square root of b squared minus 4ac over 2a. Now we have to write down the values of a, b and c which come from this quadratic equation. So a is the coefficient of the t square term, which is 1. B is the coefficient of the t term, which is negative 2. And C is the number term, which is 0.5. So now we can sub in the values in the quadratic formula. So we get t equals, so minus negative 2 plus minus, and then negative 2 square minus 4 times 1 times 0.5 over 2 times a, which is equal to 1. So now we have to simplify this expression. So in the numerator we get 2 plus minus, and then we get 4 minus 2, because 4 times 1 times 0.5 is equal to 2 over 2. So we get t equals 2 plus minus square root of 2 over 2. Now we can break it up into two fractions. So we get 2 over 2 plus minus square root 2 over 2, which can be then reduced to just 1, and then plus minus. So square root of 2 over 2 is equal to 0.71. So there is a very important step you need to understand and memorize. Now we can break it up into two cases. So the first case is the positive case, 1 plus 0.71, which is equal to 1.71 minutes, because that's the given unit of time. And then the other case is t equals 1 minus 0.71, which is equal to 0.29 minutes. So these are the two times at which the velocity of the train is 0.5 kilometers per minute. So these are the steps you have to keep in mind to solve this problem. Now we can analyze the second problem. So as per the second problem, tangents are drawn from the point 0, 3 to the parabola y equals negative 3x squared. So find the coordinates of the points at which these tangents touch the curve. Now for this problem, so I can draw a sketch, so just to help you get a visual understanding of what is going on in this problem. So there is a parabola. So this is a parabola that opens down. So if I can just sketch it here. So it's a parabola somewhere like this, right? And then there is a point 0, 3. So somewhere here on the y-axis. And from this point, we are drawing tangents to the parabola. So they go somewhere like here, right? And maybe another one in this direction, right? So now we are given the coordinates of the point from which the tangent are drawn. So 0, 3, and we have to find the coordinates of the points at which these tangents touch the curve. So let's assume so the tangents touch the curve at these points where the x coordinate is x. Now the y coordinate of this point will be equal to negative 3x squared, because the equation of the parabola is negative 3x squared, y equals negative 3x squared. Then so for every x value, the y value will be negative 3x squared. So this is a very important step you need to understand and memorize. Now we have to find the coordinates of the points at which these tangents touch the curve. Now the first thing we'll do here is to find the derivative of the given function equation of the parabola to find the expression for the slope of the tangent. So for that we'll have to do the derivative of this function. So m equals y prime, which is equal to the derivative of minus 3x squared over dx. Now negative 3 is a coefficient, so we can move it to the front, and then derivative of x squared. Now we can use the power rule to find the derivative of x squared. So it will be negative 3, and then we bring the exponent to the front and subtract 1 from 2. So we get m equals negative 6x. So this is the expression for the slope of the tangent. Now we also have 2 points that lie on the tangent. So the given point 0, 3 from which the tangent is drawn, and then the other point at which the tangent touches the parabola. So we can use the slope formula to find the expression for the slope of the tangent. So it will be m equals, so the slope formula is y2 minus y1 over x2 minus x1. And now we can sub in 2 points. So y2 can be, so negative 3x squared minus 3 over x minus 0. Now this expression can be simplified to m equals negative 3x squared minus 3 over x. Now we have two expressions for the slope of the tangent, and since it's the same tangent, these slope expressions should be equal to each other. So I can use a different color. So our equation will be, so negative 6x equals negative 3x squared minus 3 over x. So this is the equation we have to solve to find the value of x. So the first step is to cross multiply the x, or we can multiply both sides of the equation by x. So we'll get minus 6x squared equals negative 3x squared minus 3. Now we can move the negative 3x squared term to the left side of the equation. So we should add 3x squared to both sides. So the x squared terms on the right side cancel each other out. So negative 6 plus 3 is equal to negative 3. So we get negative 3x squared equals negative 3. And now we can divide both sides by negative 3. So the negative 3 is on the left side and on the right side cancel each other out. So we get x squared equals 1. And now to get the value of x, we have to apply square root to both sides. So on the left side, the square and the square root cancel each other out. So we get x equals plus minus 1. So that means there are 2 points at which these tangents touch the parabola. Now we have to find the coordinates of the point. So that's why we have to analyze these two x values separately. So let's start with the first one, x equals 1. So we'll have to sub in x equals 1 in the equation of the parabola to find the y value. So it will be negative 3 and then 1 squared, which will be equal to just negative 3 times 1, because 1 square is 1 into negative 3. So the first point is 1, negative 3. Now for the second point, we'll have to use the x value, negative 1, and we'll sub in this x value in the equation of the parabola. So we get negative 3 times negative 1 squared. Now negative 1 square is equal to positive 1. So negative 3 times positive 1 is negative 3. So the other point is negative 1, negative 3. So these are the 2 points at which these tangents touch the curve. So these are the steps you have to keep in mind to solve these two different types of problems using the derivative rules. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.